Resources Educator at Cornell Cooperative Extension of Delaware County. And my co-conspirator is Lindsay Pashow from Harvest, New York. And we are both really excited today to have Jingjing Yin with us. Jingjing is actually a commercial horticulture educator. That's her official title. And she is serving 4 counties in the capital region, and she covers ornamentals, flowers, all kinds of really interesting things. So we're so excited to have her here today to talk about soil health. And then after a short break, we'll have some folks join us from Brookville Irrigation to tell us all about that. So take it away, Jingjing.
Thank you so much, Carla. Thank you for having me today. I'm going to share my screen. Can everyone see my screen well? Okay, good. Hello, everyone. I'm Jingjing Yin. I'm the commercial horticulture educator with Cornell Cooperative Extension, Capital Area Agriculture and Horticulture Program. So today I'm going to talk about soils and soil health. So the first question is, what is soil health? Soil health is an assessment of how well soil performs all of its functions now and how those functions are being preserved for future use. So the functions healthy soil can perform include regulating water, sustaining plant and animal life, filtering and buffering potential pollutants, cycling nutrients, and providing physical stability and support. So this is the definition from USDA. So when we evaluate soil health, we need to look at 3 properties of the soil: physical property, biological property, and chemical property. So let's take a look at the physical property first. The first thing we're gonna take a look for soil physical property is soil components. There are 4 fundamental components of a soil. There are about 45% of minerals, 5% of organic matter, 20 to 30% of water, and 20 to 30% of air. So these percentage numbers can change based on the time of the day, the time of the year, the weather, soil type, or how you manage the soil. For example, like if you have clay soil, the organic matter in your clay soil may be around like 4 to 6%. And if you have sandy soil, the organic matter in your sandy soil probably is only around like 1%. So these percentage numbers can change a lot. The next thing we're going to take a look of soil physical property is soil texture. The look and the feel of a soil is referred to as soil texture. So soil texture is determined by the size and the type of particles that make up the soil. So when you sift out the larger pieces of rock and gravel in your soil, the small particles left behind are sand, silt, and clay. So you can see sand with your naked eyes, but usually you cannot see silt and clay with your naked eyes. So silt feels smooth and silky when it's wet, and the clay can actually stick to your fingers and it can be molded into shapes. So the surface of the clay particles is negatively charged. That means the positively charged the nutrient elements can stick to the surface of the clay clay particles. So that also means the higher percentage of clay in your soil, the more nutrients can be held in your soil. So soil texture is very important because soil texture is the only soil physical property that you cannot change. Like if you have clay soil, then you have to stick with your clay soil. And then if you have sandy soil, you have to stick with sandy soil and deal with your sandy soil. So can you add sand into your clay soil, trying to increase the percentage of sand in your soil? The answer is no. So if you add sand into a clay soil, you will end up having concrete, not soil, because the surface of the sand has perfect, so the sand particles has the perfect surface for clay particles to stick on. Since soil texture is so important and you cannot really change, so before you start farming or gardening, you want to know what kind of soil texture you have. So how can we figure out what kind of soil texture we have? One way is to use this jar test. So this jar test is, so you collect a soil sample and you fill a glass jar with your soil sample about like half full. And then you fill the jar 2/3 full with water. And then you shake hard for 3 minutes. Then the sand and the large particles fall to the bottom first. And you mark this level with a marker. And you leave the jar for a few hours. Check it again. And this new level is the silt component. Mark this level. And now you leave the jar sit there for another 24 hours. And when the water is clear, mark the top layer, which will show you the clay component. So from these 3 marks on your jar, you can work out the percentage of sand to silt to clay. And then you use this soil texture triangle to figure out what soil texture you have. So when I'm in the field and if I want to know the soil texture immediately, I don't want to wait for 24 hours. I usually do a ribbon test. So if a soil can form like a flat and a long ribbon shape in my fingers, so that means the soil is quite clayey. And the next important soil physical property we're going to take a look is soil structure. Soil structure is the way that individual sand, silt, and clay particles stick together. So when you pick up a handful of soil and it breaks apart into like small pieces, like these pieces can be like smaller or bigger. So these pieces are actually called soil aggregates. So there's some like small soil aggregates and bigger soil aggregates. So this aggregate is made up of soil particles of sand, silt, and clay. So they are held together by both the attraction of soil particles and the binding of organic matter between these soil particles. So you can imagine if you have higher level of organic matter, the soil aggregates in your soil probably are bigger, right? So the good soil structure provides homes for soil organisms and pockets that hold on to soil water and nutrients. And poorly structured soil, on the other hand, may have poor drainage, resist root growth, lack fertility, or not have enough air and water for living organisms. So we talked about soil physical properties. Now we're going to take a look at soil chemical properties. When we talk about soil chemical property, the first thing we're going to look at is soil pH. We all know about soil pH. Soil pH is very important. So soil pH measures the acidity or alkalinity of a soil. So a soil pH of 7 is considered neutral. Less than 7 is acidic, and higher than 7 is alkaline. Damn it. So there are some, so for most plants, they prefer soil pH being between like 6 to 7. Like our cut flowers. Our cut flowers also prefer soil pH between 6 and 7. But there are some acid-loving plants, such as like blueberries and some Christmas trees, they prefer soil pH being around like 4.5 to 5.5. So another reason why soil pH is so important is because it is a primary factor controlling nutrient availability to the plants. So when soil pH is maintained at the proper level, the macronutrients and micronutrients can be available to the plants, and the toxic elements can be minimized to the plants. And also, the soil microorganisms are actually very sensitive to soil pH. So if you have like a higher soil pH, you want to reduce your soil pH, then you add sulfur into your soil. And the best time to add sulfur into your soil is in spring, when soil temperature is at least 55 degrees, because this process needs bacteria to convert sulfur into sulfuric acid. So it's actually a biological process. It needs bacteria to work. So during the winter time, bacterial activity is not active. So you don't want to apply sulfur in the fall, because it's not gonna do anything. So apply sulfur in the spring when the bacteria start to be active. And if you have like acidic soil and you want to raise up your soil pH, then you need to apply some lime. And the best time to apply lime actually is in the fall, because it takes a few months for the lime to raise up the soil pH. So we talked about soil pH, and then we're going to talk about the nutrient elements. There are macronutrients and there are micronutrients. The 8 micronutrients I list here, they are needed in much smaller amounts than the macronutrients. And among the macronutrients, there are these 3 major macronutrients we always pay lots of attention to: nitrogen, phosphorus, and potassium. So if you go and buy fertilizers, you often see 3 numbers in the packet on the package, like 10, 10, 10, 20, 0, 20, something like that. So the first number is the amount of nitrogen in the fertilizer. Nitrogen is very important because it's important for the plants to grow bigger, grow stronger, and grow more leaves and branches, and also important for the color green. And the phosphorus is very important for like root establishment, root development, and also for like fruiting and flowering. So as a cut flower farmer, we need to pay lots of attention on phosphorus in our soil. And the potassium is very important for like photosynthesis, for water and sugar transportation in the plants. So during the dry summer, potassium actually can help the plants. However, one of the things we often forget is that nutrients actually have relationships with each other. So this is Mulder's chart. This chart tells us that the nutrients can affect each other positively or negatively. For example, calcium and zinc, they have the negative relationship to each other, which means the more calcium we have in the soil, the less ability the plants would have to uptake zinc. So if we take a soil test and we have lots of calcium in the soil, but the plants may still have zinc issues because there's too much calcium in the soil. So the plants cannot uptake zinc from the soil. So adding too much nutrients in the soil is not good. I have to say it's probably as bad as not having enough nutrients in the soil. And there are some other nutrients that work together. For example, nitrogen. Nitrogen has the positive effect on magnesium absorption, which means more nitrogen can help more magnesium to be absorbed. Okay, so we have talked about soil physical property and chemical property. Now we're going to take a look at the biological property. I have to say the biological property is very, very important. And of course, when we talk about the biological property, we're going to talk about organic matter. Organic matter is super important and super powerful. So organic matter can absorb 6 times its weight in water, and it can hold our nutrients like a magnet, and it can build a soil structure, increasing pore space for water and air, and also can feed good microorganisms and worms. So let's take a closer look at organic matter. There are three components in organic matter: the living, the active, the stable. So we're going to take a look at the living first. So the living is the component in the soil organic matter that is alive, such as like fungi, bacteria, nematodes, insects, and worms. So if you take a handful of soil, there's lots of living organisms in the soil. From this table, we can see that the numbers are huge, right? So there's so much living organisms in the soil. And the next component is active. So the active, this is recently dead and actively decomposing. And this is the most important portion of organic matter. So this is the active component. This is the main food supply for the living soil organisms. And the soil organisms, release the nutrients from soil organic matter to the plants, as well as binding the soil aggregates to make our soil more stable. Sorry. So studies have shown that when we compared apple production at two apple orchards, the other conditions were all the same, like same type of soil, same types of apple varieties, and the same management practices. But when there was higher portion of active organic matter in the soil, the apple production was also higher. So we can see this component in organic matter is very important. And the last portion in soil organic matter is the stable. So this is the organic matter that has been broken down and not much left for nutrients. Sometimes we call it humus. Although there's not much nutrients left in humus, it can provide habitat for microorganisms to live. So it's still very, very important. So the next question is, how do we build up soil organic matter? So the best and the quickest way to build organic matter in the soil is to add manure or compost into the soil. There are so much living organisms in manure and compost. So mulch is also a way to add organic matter to soil, but there are not as many living organisms in mulch than manure and the compost. So manure and the compost, they're great. Another way to build up soil organic matter in the soil is no-till or minimum till. So soils that are tilled frequently are usually low in organic matter because tilling decreases residue particle size and increases the amount of air in the soil, which increases the rate of organic matter decomposition. And another way, also an important way to build up soil organic matter is grow cover crops. So there are a few types of cover crops, but legumes and grasses are the most extensively used. Grasses are like rye, like winter rye, like oats. Legumes are like peas, soybeans, clovers, like white clover, red clover, and hairy veg, So legume can fix nitrogen and add more nitrogen into the soil. And the grasses can scavenge nutrients from the soil. And you can grow cover crops before a main crop, or during the growth of a main crop, or after you harvest the main crop. Like if you grow cover crops before you plant a main crop, it gives you an opportunity to add more organic matter into the soil, but you want to make sure you let your cover crops to grow big, because we can see, so from this picture, we can see cover crops, if you let them grow big, it has huge root mass, right? This huge root mass is very, very helpful for our soil because first, this huge root mass can provide lots of organic matter into your soil. Also, you can see this huge root mass, they can penetrate the soil. And then if you have clay soil, it can break down the clay particles for you to improve the drainage or the soil structure of your clay soil. Or if you have sandy soil, like this huge root mass can provide so much organic matter and to bind, your soil particles together to increase the size of your soil aggregates, and also can increase the capacity of your soil to hold on nutrients and water. So it's great. And also the above ground, if you terminate these cover crops, and you left these above ground part on the soil, it's also a good amount of organic matter for your soil. So if you grow cover crops before planting a main crop, let them grow big, and then it will provide a good amount of benefits to your soil. And if you grow cover crops during the growth of a main crop, the cover crops can be used for weed suppression, right? And also can also improve the soil health. But one thing you may want to be careful is, especially some grasses, be careful. These cover crops may have the competition with your main crops for water and the nutrients. Then it will negatively affect the growth of your main crops. And if you grow cover crops after you harvest a main crop, it's also great because, first it can add, if you grow legumes, it can add more nitrogen into your soil, right? And it can also cover your soil because you never want to expose your soil. You always want to have your soil being covered by something. And also, if you apply too much fertilizers, and during the winter time with the rain and snow, the nutrients may leach. So if you grow cover crops after you harvest your main crop, these cover crops can scavenge the nutrients into your soil and store these nutrients in these crops. And then when you terminate these cover crops in the spring, then the nutrients can be recycled into the soil. So that means these nutrients you applied too much before will not be wasted, to save your money. So it's great. One thing I want to mention is like if you only grow, for example, when you decide to grow cover crops, right? And if you only grow grasses and you let them grow bigger, wait until they're mature, one issue will be, so for grasses, the carbon to nitrogen ratio is actually higher than legumes. So that means if you terminate these grasses and leave them in the soil, when they're decomposing, it may bind nitrogen from your soil because when they're decomposed, they need nitrogen, so it may uptake the nitrogen from your soil. So sometimes when people grow cover crops, they will mix grasses with legume together. So that means the legume can fix the nitrogen and add more nitrogen into the soil. So when grasses are being decomposed, when they need nitrogen to decompose, and then they have this extra nitrogen in the soil for them to use. So you often see people, like mix grasses and legume together. So this is a great cover crop. So this is a great website for cover crops. So if you have time, please spend some time to explore the information on it. So it gives you lots of cover crop options, and it tells you like how to plant these cover crops, how to maintain them, and how to terminate them, and like when to plant like certain cover crops. So it's great. It has lots of great information on it. So if you miss the windows of growing cover crops, or you are too busy to grow cover crops, leaf litters is also good. The nice thing of leaf litters is, so in leaves, nitrogen content is usually high. So when they are being decomposed, they will not bind too much nitrogen from your soil, especially if you use like composted leaf litter. It's great. It's great for your soil. The only problem is not only problems. Sorry, one of the problem is the leaf litters tend to be very, very light, so it's easier to be blown away. So you may want to, like during the fall or the winter time, you may want to use some kind of like netting to cover these leaf litter, and you use some like rocks, to put on the corners of the nettings to make sure the netting stay there. So if we want to know more about your soil, like your soil organic matter level, the nutrients level, you can do a soil test. And this is a list of soil testing labs that I have sent soil samples to, and they are good. So for example, if you send a soil sample to a soil sample for a basic soil testing to Agri 1, you will receive a soil testing report like this. So it will tell you the macronutrients level and the micronutrients level in your soil, and it will also tell you the organic matter percentage in your soil and the pH, and it will also make some soil fertilizer recommendations for you. So it's great. So for our cut flower farmers, one thing you want to be careful is if you decide to send your soil sample to Agri 1. So if you go to Agri 1, so if you go to the website of Agri 1, you will find a few soil submission forms like Form H, Form F, Form A. So you may wonder what kind of form I want to fill out, right? Theoretically, like for our cut flower farmers, the form we want to use is Form H, but Form H actually is for home gardens. So it will not tell you much information. Everyone has changed their report format. So for Form H, the soil test report you will get will only tell you your soil pH, the phosphorus level in your soil, and the organic matter percentage. So not much information. You will not get a report like this. And then if you fill out the Form A. So Form A is for field crops like soybeans, like corns, So if you fill out Form A, it will tell you that much information in the soil test report. However, the soil fertilizer recommendation you will get is based on field crops like corn and the soybean. So what you will see sometimes is, I have seen that before, is, oh, my soil pH is 6.5. It's great for growing cut flowers, right? But in the recommendation section, it will tell you to apply limestones to increase the soil pH to 7 or 7.2. So that is not right. You don't want to, apply more to raise up your soil pH from 6.5 to 7.2 to grow cut flowers. So if you are concerned about the recommendations, please contact your local cooperative extension. Okay. And also sometimes I have seen some mistakes about this levels, like for example here I think it's a mistake, like magnesium level here, the number here is 85 pounds per acre, and it shows you it's very high, but I think this number is not very high. It's actually low to me. And so this one is the basic soil test, and you can have this basic soil test done every year or every other year, the best time to submit your soil sample for a test will be fall or early spring. And the next soil test is a comprehensive assessment of soil health. So this will tells you more information about your soil health, and you don't have to do this soil health test every year or every other year, because your soil health will not change too much year to year. Usually, you can do it like every 5 years. So the cost of basic soil test is about $18 to $20. And for this soil health test is about $160 to $200, depending on what kind of information you want to get from your test, right? You can send the soil sample for soil health test to Cornell. Let's take a close look at this report and see what kind of information they provide, okay? So first, it tells you your soil texture. You can see there's 2% of sand, 83% of silt, and 15% of clay. So the soil texture for this soil is silt loam. It's good, right? Then it tells you the physical properties, biological properties, and the chemical properties of your soil. And we have talked about this. Let's take a look at this one by one. So for physical property, first is the available water capacity. It also in this report, it gives you the value and the rating of this indicator. The available water capacity is the water that is available immediately to your plants. So here, this value is 0.14 and the rating is 37. It's not great, right? And the next indicator is surface hardness. So surface hardness, it measures soil compaction of the top 6 inches of soil. Usually that is root zone. Like if you use collected soil sample for basic soil test, you want to collect a sample from the top 6 inches because that's the root zone. So this value is 260 psi. So we use this penetrometer to measure the soil compaction. If you want to measure soil compaction for your soil health test, Cornell will send you this penetrometer. It's expensive. It's over like $200, so you don't need to buy one. Cornell will send you one, and after you use it, you just send this back. So usually, if the soil compaction is between 0 to 200, it's good. And 200 psi to 300 psi, it's fine. And over 300 psi, it's too high. Roots cannot penetrate. Roots cannot penetrate in the soil when its compaction is over 300 psi. So here we can see the subsurface hardness. Subsurface hardness measures the soil compaction from 6 to 18 inches deep. We can see the value here is 340 psi. It's not great. And then the next thing is the aggregate stability. Aggregate stability, it measures soil structure, seeing how soil aggregates resist falling apart when hit by raindrops or being wet. So the value here is 15.7, and the rating here is low. So that means the soil aggregation of this field is not good. So this field may have some erosion issues and a runoff issues. And then let's look at the biological property in this test. Organic matter 2.5, okay, right? For silt loam, it's okay. And the ACE soil protein index. So ACE soil protein index measures organically bound nitrogen in soil organic matter, which can be released by microbial activities. So that is the potential nitrogen that is available to your plants. So we can see the rating here is 25. It's not great. And soil respiration. Soil respiration measures the metabolic activity of soil microbial community. So it measures how much soil microorganisms in your soil. The rating here is 40. It's okay, it's not great. And then the active carbon. The active carbon is the energy source for soil microorganisms. So we have talked about this before. And the active portion of organic matter, this one is very important. And we see the rating here is 12, so it's not good. And then we see here is the chemical property. Soil pH 6.5 actually is good. And then the phosphorus, potassium, and then some micronutrients, these are all good. So from this soil test, this soil health test report, we can guess this field probably is conventionally managed. So it puts lots of probably the farmer added lots of like conventional fertilizers in the soil. So it has lots of nutrients that are available immediately to the plants. However, the physical and the biological properties, these indicators are not great. So this field probably has been tilled a lot. And my suggestion for this field will be build up organic matter. That this is super important. Build up organic matter to improve the biological properties of the soil. Then it will eventually also improve the physical properties of the soil. So for soil testing, for the basic routine soil testing, these are the things I think are important. First is sample at the same time of the year. So you can compare the numbers from your soil test report. And then sample to the same depth, like to 6 to 8 inches deep. That's the root. So usually we do 6 inches deep. And run the same tests. So you always want to send your soil sample to the same lab because different labs use different methods to do the test. So the numbers from different labs are different. You cannot compare. Send your soil sample to the same lab. They have the same test, so you can compare the numbers year to year. And also keep track of fertilizer applications and the plant's growth. And there are a few other tests I think are very useful and helpful for our cut flower growers. One is the leaf tissue test. So leaf tissue test is the measure of what's in the plant versus what's in the soil. So usually when we, so you collect the leaf tissues during the growing season, and you send your leaf samples to the lab. Usually you want to send a soil sample with the leaf sample together because we want to compare the nutrients in the plants and in the soil, see what's in the plants and what's in the soil. And you want to collect a pint of like recently just matured leaves. You don't want to collect the new leaves because the new leaves haven't absorbed enough water yet. And then you also don't want to collect those old leaves, collect the recent matured leaves and put these leaves in a paper bag. For soil samples, you want to put them in a plastic bag, right? Leaf samples, paper bag. And send it to a lab. And the leaf tissue test is more accurate for specific nutrients like boron, like sulfur. Another test I think is useful is irrigation water test, especially if you have high tunnel, especially if you grow like flowers in the tunnels. You want to know about your irrigation water, like the soil pH, that kind of thing. So let's take a look at this report. This is a leaf tissue test report from Waters Agriculture Lab. I like them because they're very, very fast and they're relatively cheap. So like they will give this test report to you 1 day after they receive the sample. So they're very fast. Like for everyone, usually it takes about 5 to 7 days. And for university man testing lab. I like them. However, they're very slow. Usually it takes about 2 weeks for them to get back to you. So this is a report from Waters Agriculture Lab. You can see this is, they put this plant analysis and the soil analysis together, right? So you can compare what's in the plants and what's in the soils. You can see in the soils, these nutrients are all, like most of these nutrients are good. They're at a high level, right? But however, you can see the nutrients in the plants. These are low. So that means the plants are not be able to uptake these nutrients from the soil. Why? Why is that? We have talked about before, right? Adding too much nutrients is really not good. It's actually as bad as not having enough nutrients in the soil. Because you can imagine if you don't have enough nutrients in the soil, you probably will get a plant analysis like this too, right? So this is actually wasting your money. This is a water analysis, the irrigation water test report from Penn State. So I'm not gonna take a close look at this because we are having a presentation on water. Okay. So the take-home message: how to manage the soil health. You always want to feed the soil. You always want to build up soil organic matter in the soil, and also keep the soil surface covered, and minimize soil disturbance and compaction, and always keep living roots in the soil as much as possible, and also add diversity in crops and include livestock when possible. Okay. Okay, thank you. This is what I have today, and I'm happy to take any questions.
Any questions for Jingjing today?
I'm gonna close this.
All those questions about where to find your organic material, where to buy your cover crop seeds, all that good stuff. I bet she's full of information.
Yeah, so where to buy, where to buy organic materials like compost and manure. So for manure, you may want to check with your local livestock farmers. They may have manure and they can sell you. For compost, so I think for most counties, they have a compost facility, and you can get those compost for free. For example, I know in Albany County, there's a compost facility, and our gardeners and farmers, if you have a truck, you can just go and get a truckload of compost. Yeah.
Yeah, you do have to be really careful though. Make sure you call your extension office first before you go after the county compost, because I know in Delaware County, it's actually the pH is a bit high and it has some glass in it because it's made out of human waste and organic materials. And it's fine for like a landscaping program, but not necessarily, especially if you're going to eat the stuff. For cut flowers, it's probably fine. But again, you really want to check depending on your county.
Yeah, and also for manure, one big problem of using manure is the weed seed. There's lots of weed seeds in it, especially if the manure is not properly composted. Properly compost is, when you're composting the manure, the temperature was not high enough, then it will not kill these weed seeds. So when you apply the manure into your soil, you will get lots of weed.
Right. And then you have to be careful too. We had a situation in Delaware County where somebody got manure from a high-end horse farmer, and the horses were fed a very special hay that had been treated with herbicides. And that went through the manure and actually ruined their crops. So, I think it's a good idea, just word of mouth with other farmers and your extension agent, just to see where the good places are to get them. But I know that when I was first starting out, that was something I really struggled with. Like, I know I need this stuff, but where do I get it? You know, what's good?
Yeah, especially, like before you get large amount of manure or compost, you always want to know about the about the material first.
Okay, Jenny would like to know, are perennials better for soil health?
The question is if the perennials are better for soil health. So do you mean like growing perennials?
Yeah, I mean, I guess how they would like retain the soil in place and prevent erosion, but it's also, I would think, and I'll let you answer this, but that you would need to keep adding amendments anyways, even though you're not.
Yes.
Yeah. So they're always in the soil.
So for perennials, like our cut flowers, they grow perennials. It's very common. So for perennials, you also, you need to maintain the soil health for them. Like usually in the fall, you can add some compost to your perennials, and the compost will slowly release the nutrients into the soil and to feed your plants.
Okay, and Gina would like to know, what's the best way to terminate a cover crop without tilling?
Oh, yes. Well, there are a few ways, so you can mold them, and and leave the residue in the field. And I know some farmers, they use herbicide to kill them, And for some cover crops, they're not hardy for the winter here. So the winter can kill them. For example, if you grow oats, it's not hardy enough to overwinter. So the frost here can kill the oats, and then you just leave the oat residue in the field, and then they'll be ready in the spring as mulch, as a mulch for you to grow cover crops in it.
Great. Now, would you test multiple parts of your land if you have large acreage for your soil test?
Yes. So like if you, for example, like if you grow cut flowers in multiple high tunnels, right? I will do one soil sample for each high tunnel, and also like if you grow perennials in this field, and you do one soil sample just for perennials. And if you grow like annuals in another field, then you do another like soil sample for the annual field. And if you found out, oh, I grow annuals in this big field, but half of them grow well and half of them don't grow well, then you may want to take one soil sample from the area that plants grow well, and another soil sample from the area that where plants don't grow well, so you can compare what's going on here.
Great. Okay, any more questions? Okay, well, let's all thank Jingjing for her insight into soil health. It always seems so confusing to me. I think it's such a mystery. But really, there's just, she laid it out very well, that there's just a few basic things that you need to take care of to keep everything in balance, right?
Yeah, thank you so much, Carla, for having me today. But one last thing I want to emphasize is, I always think the biological property of soil is very important. So please pay lots of attention on your biological properties. Okay.
Excellent.